Good morning, Tahmina Khan is here in TKMaths is Fun. In today's video, we will continue A-Level Mathematics M1 lessons. We are on lesson 2, which is on distance, velocity and acceleration. And in this video, we will cover part 3 of point 6, which is graphs with discontinuity. For the rest of the videos, you will find the link in the description. Rather, I will put there the playlist link so that you can have the availability for all the lessons which I will make on M1. So let's continue. It is 2.7 lesson. Graph with discontinuity. If you see velocity time graph here and displacement time graph here, this displacement time graph is the representation of the velocity time graph. You will see in the questions that there is no connection between two graphs or two lines to two line segment in the velocity time graph. But in the displacement time graph, discontinuity is not possible. There is an instantaneous change in the gradient. So how it happens, what are the situations, we will cover in the 4 examples or 3 examples. So let's see. So scenario number 1, if you see here, it is talking about a ball is traveling at a constant speed of 10 meter per second. So suppose it is from here, 10 meter per second for 2 seconds. This is the speed, 10 meter per second, and for 2 seconds until it strikes a wall. So now there is a wall. So it strikes. It bounces off the wall. Now let's understand through diagram, and then we will not need to read the diagram questions again. It strikes back with a speed of 5 meter per second and maintain this speed until it reaches the starting point. So it has come back all the way here. And then it passes this point and decelerates at this. When it is written like this, it means there is a continuous or uniform deceleration. And of course, if there is a uniform deceleration, after some time it will stop, right? So then it decelerates at 1 meter per second. So from this point onward, it decelerates, and suppose it stops here, okay? Find the time and displacement in each phase of the motion. Now what does this mean? If I see there are 3 phases. One phase is from the starting point to the wall. Second phase strikes back or bounce back from the wall and come all the way back to the starting point. And then after that, from the starting point to the deceleration and come to rest. So we have to find the time and displacement in each of these 3 phases. Okay, so I have written here to remind you the formula, speed is equals to distance divided by time for constant speed, and for constant deceleration also SWOT equations we have done in the previous questions. So let's start phase 1, okay, this one. Okay, so now what happened, we know the speed is 10 meter per second and time is 2 seconds. So what distance is covered? Very right, speed into time. So it is 20 meter covered. So let me sketch here roughly for better understanding. So this is 20 meter. Okay. Now it will strike back from here. When it will strike back, the speed has reduced. Now it is 5 meter per second. Earlier it was 10 meter per second and the time was 2 seconds. Now it is coming back here. We know the distance is same 20 meter because it is coming back to the starting point. So how long will it take now? What will you do? Yes, you are right. You can do distance divided by speed. That will give you 4 seconds. So it will take 4 seconds to come back. So altogether from the starting point and striking and then coming back to starting point, altogether it is 6 seconds. We will need these timings when we will be sketching velocity time graph and displacement time graph. Now what happens? At this point, till here, it was 5 meter per second because it was written in the question, maintain that speed until it reaches its started point. So now after that, constant deceleration starts and then object will come to rest. Okay, so now we have to find out the time. So if you remember the SWOT equation, V is equals to U plus AT. At this point velocity will be 0 because we have to find out for this phase when deceleration starts. So v is 0 and velocity is in this direction, right? Initial velocity. So minus 5 plus a will be what? 1 and t. Now somebody may get confused when it is deceleration, the word is written here, then why we are not taking minus 1. So please remember in the first video when I was talking about arrow convention, I explained it to you. So when it strikes back from here, right, acceleration is acting backward. I'm talking about this point. Acceleration is acting backward. It is minus 1. When we change the arrow and bring it align with u, it will become 1. So that's why we take a is 1. So it is 0 minus 5 divided by 1 equals to t. So t equals to 5 seconds. So it will take 5 seconds to come to rest. So altogether, how many seconds it has taken for the whole journey? 2 plus 4 plus 5. So 11 seconds. So we have found the time in each second. Now only displacement in last second is left. So now we know the displacement for other two segments. But for this one, how much distance covered we have to see. So what is coming in your mind? Again, S is equals to ut plus half at square. Right? So other formula is also there. You can use that, no issue, whatever you like. So u is 5, t is 5, half a is minus 1 and t square. And you calculate it. What will you get? S is equals to minus 12.5 meter. It means this distance covered here is 12.5 meter. Right? So now after that, let's see the sketches. So can I erase all this to make it little clean? Okay. Let me show you here. Okay. So now we know the displacement in the last segment is 12.5 meter in the opposite direction. That's why there is a negative sign. Okay. Okay, so now let's see velocity time sketch first. If you see here, the ball was traveling with the speed of 10 meter per second for 2 seconds. So it will be 2 seconds here. Here, it will be 2 seconds. So this is first line. After that, there is discontinuity. Why? Because it bounces back. When it bounces back, the speed is 5 meter per second. So you will draw this line 5 meter per second from here onward. And we have seen that for next 4 seconds, it take time to come back to the starting point. So that's why this line will end here and we will write here 6 because 2 plus 4 is 6. And after that, what happened? Constant deceleration at 1 meter per second until it come to rest. And that's why it is very important to mention here 11, the total time of the journey. Now let's change all this velocity time graph into displacement time graph, right? So what will happen to this part of the graph? You tell me. It is going with the constant speed. It means in displacement time graph, it will go like this. We have seen this in the previous video. And then for this part, because it is negative acceleration, it bounces back and it will come to rest. So it will be 6 seconds here. Clear? And after that, what happened? Deceleration. Okay. So in displacement time graph, it will be curve. So I hope you understood it. And after that, I will explain it to you. Rather, I will give you for your testing how much you understood this scenario, these two scenarios. So you can put the video on pause, try it out, and I will show you the solution. And in case if you don't understand any part of this solution, you can write in the comments. So you can put the video on pause, try it, and I will show you the working. Okay. I'm not going to explain it to you. You will match your working with this, and if you don't understand, then write it in the comment box and I will explain it to you. So I hope you have marked your working. And for the next part, I'm using the concept of gradient also, in the velocity time graph, the gradient gives you what? Acceleration. Because the second question is about sketch a velocity time graph and a displacement time graph, just like the first one. Here one thing remember, if you look at this line here and here, right? If the steepness is less, it means what? Change is happening slowly. And if its steepness is more, then in the displacement time graph, change is happening faster. So that's why you can see here, it is like this, slow change, and here it is high change. So slowing down with faster rate and then slowing down with slower rate. So I hope you understand this. If you have any question, you can ask in the query. Thank you very much for watching the video. In the next video, we will see the past paper questions and then this topic will end. Thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.